Hello, today I'm going to talk about expression for drain current in MOSFET. That is, IDs. We're going to find equation for IDs in different regions. Before that, just a brief is that what is N-type and difference between N-type and P-type are in N-type semiconductor the majority charge carriers are free electrons, whereas the holes are in minority. In P-type, the majority of charge carriers are holes, whereas the free electrons are in minority. Now, when we come to the MOSFET, the main difference between NMOS and PMOS are, in NMOS, the source and the drain terminals are made of N-type semiconductors. In PMOS, the source and drain, that is source and drain, are made up of P-type semiconductors. Okay. Now when we consider for IDS equation, that is drain to source current, we need to consider this a source and drain. Now between source and drain a channel is created, and here the VGS is applied in the channel. So that is VGS should be always greater than the threshold voltage, that is VGS minus VT should be greater than 0. Then only we get conduction. And this equation is called as overdrive voltage, where the difference should be more positive, that leads to more conductivity, and that leads to more current. In order to have the more current across the channel, the electrons should be moving. So the VGS voltage, that is VGS minus VT voltage, should be greater than the applied voltage. Then only carriers will move. That means we need to subtract the applied voltage from VGS minus VT. Okay, that is here V is applied voltage. For current, Q is equals to charge by T. Whereas Q is equals to C is V dash, where to differentiate this V and this V, I have put bar. C is the capacitance. Now it is given as what? C is epsilon oxide, that is epsilon oxide is permittivity of the oxide, into A, that is cross sectional area of the channel, and T is the thickness of the oxide, into V is given as VGS minus VT volt minus applied voltage. Okay. Now here we consider C0x, that is Q is equals to C0x, that is capacitance of the oxide, into W by L. Why we have written width into length is because cross sectional area of the channel is equals to width into length of that channel, that is WL, into VGS minus VT minus V, that is net gate voltage. This VGS minus VT is net gate voltage. Okay. The capacitance, this one can be also written as C by A, that is epsilon permittivity of the oxide divided by thickness of the oxide. Get it? That's the reason we have written, we can take capacitance is equals to epsilon. This one is substituted with C0x, because capacitance of the oxide can be written as permittivity of the oxide divided by thickness of the oxide. Now we substitute this into this equation 1, that is current is equals to Q by T. Here the current is drain to source current is equals to capacitance of the oxide into W into L by T, VGS minus VT minus V. We have substituted. The result equation is capacitance of the oxide into width into this L by T can be written as VD. VD means drift velocity of the charge carriers from source to drain. Source to drain. This can be, that is VD is the this can be substituted with VD. Therefore, IDS is equals to capacitance of oxide into W into mu E. E is called what you say, applied electric field, and mu is the constant. Now when you substitute, we get VD is equals to IDS is equals to VGS minus VT minus V. When we substitute in that, we get as mu C naught x W VGS minus VT minus V dV by dt. Why we consider dV by dx is, here applied electric field is equals to V by D. That's the reason we consider dV by dx. Now what happens is, this dx comes this side, Vdx into V dx is equals to mu C naught x W VGS minus VT minus V into dV. Now when we applied integration on both sides, we apply integration from 0 to L, that is the length of the channel, and here 0 to VDS, because it respect to the voltage, 0 to VDS voltage. What happens is, when we substitute, integration of dx is x, and that is from 0 to L, so L being the uppercase, IDS is equals to L minus 0 is equals to mu C naught x W VGS minus VT into VDS minus VDS square divided by 2. We have integrated, right? Integration of that we get is this VDS square minus 2 for V. So the total equation for the MOSFET is, for drain to source current is mu into C naught x W by L VGS minus VT, this L comes this side, and into VGS minus VDS square divided by 2. So this is the equation we get for small VDS. Okay, when for small VDS, for triode region, what happens, what is meant by triode region is, a channel is created when the voltage between gate and source terminals VGS is greater than the threshold voltage. Okay, that is called, when VGS is greater than VTH, the device is said to be in a triode or constant resistance. Okay, so in triode region, this VDS minus 2 becomes, this VDS becomes 0. So FET is used as a variable resistor in triode region. When it comes to saturation region, what happens, VDS is equals to VGS minus BT. So in this one we substitute, in this one what happens is, it squares VGS minus VT into VGS minus VT, that means VGS minus VT whole square divided by 2. That's what we get. Okay, we substitute here for saturation region, we get as a whole square. So the drain current is drawn to source current is equals to epsilon constant into capacitance of the oxide into width of the channel by length of the channel divided into 1 by 2 into VGS minus VT whole square. That is the IDS equation for the MOSFET. Thank you.